Our subject today will be digital imaging. We're going to take and expand upon the binary systems that we learned and see how that applies to the concepts of images. And go ahead and get this thing going here. All right. So when we talk about digital imaging, there's obviously a different multitude of ways that the digital images can be displayed. Your computer screen certainly is one of them, and a video display, as we talked about earlier in the chapter, is made up of a grid of pixels, and those pixels, depending on how many of them there are, define how nice the resolution is on your screen. If you remember, we talked about digital images in the context of cameras and how say a 8 megapixel camera would have roughly 8 million pixels arranged, which is simply the length times the width. So there are a variety of different display resolutions, but no matter how many pixels you got, each single one is formed from 3 colored lights, a red light, green, and a blue. So RGB is what they go by, the letters RGB, and always in that order. And when you're talking about a video display, one of the interesting things to note is that most video displays will only be set up to display roughly 100 pixels per inch, or PPI. Actually, you can go down as low as 72, and a lot of displays are set up that way. 72 pixels per inch is all the more resolution you need on a video monitor. Then there's a concept, bit depth, and bit depth will essentially quantify how many colors are available in a color palette. And of course, this is in terms of our binary zeros and ones, or bits, and each of these is used to specify an individual color. One way to think about this is that back when you were a kid and you had Crayola crayons, if you only had a box of 12, you had a pretty shallow bit depth, if you will, of available colors to you. Where if your buddy might have had the box that had 64 crayons in it, he had a much greater depth, bit depth in his box, lots more colors that he could choose from. So each primary color is generally referred to as a color channel, and all those different channels' intensities are specified by the bit depth. So the bit depth for every primary color is termed the bits per channel. So you get down to the question of really how much color do you really need? Well, most digital cameras today are set up to do 8 bits per channel, or 1 byte. So there's a total of 8 zeros and ones, and this would allow for 2 to the 8th or 256 different combinations. So the thing you need to remember here is that each of those 256 values from 0 to 255 translate into some different intensity of that particular color. Now if we look at all 3 primary colors that are possible, remember red, green, and blue, then we have 2 to the 8th, but it's times 3 because there's 3 colors, or roughly 16K different colors. And this is given a specific name that's known as true color. You'll often see that referenced in video monitor resolutions. They're talking about the bit depth or the number of colors that are available. So true color is roughly 16K. And this is a 24-bit per pixel because each pixel is composed of 3 8-bit color channels. Sounds a little confusing, I know, but it'll start to make more sense as we get further down through the slides. All right, enough about color. Let's talk about black and white for a minute. So if a single byte is allocated to each RGB intensity, then it makes sense that the smallest intensity would be 0. Notice that the way the numbers are displayed here, 0, a group of 4 zeros, and another group of 4 zeros. This is a hex representation. So the largest, in contrast, would be a full group of 1s. And these, of course, are shown in binary, but in In hex it would be FF, and in decimal it would be 256. So the idea here is that black, all zeros, is basically no color, and white, all Fs, has the full intensity for each color, and that means all red, all green, all blue. If you mix them together at their highest intensity, you actually get white. So here's another representation of what that looks like, but we're going to be working with hex values as we move through here. Now grayscale is a different interpretation of the range between black and white. So anything in between is gray, and at some particular level of gray or scale of gray. So those values are going to be somewhere between 0, notice 0, 0 is the red channel, 0, 0 the green channel, 0, 0 the blue channel, all the way up to F, 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 F. Okay, so anytime that these are equal, that's a clue to you that you're dealing with some shade of gray. All right, so let's try this. Here's a URL for a color code chart here on the internet. So here you can see this is a web utility that will allow you to take and pick out any particular color. You'll notice as I drag the pointer around here through these grays and blues that the representative color over here in this square box changes, and also the values down here of RGB also change. You'll see that we have the hex representation down here for that particular color, and I can change the primary color by clicking on this bar here. So if I wanted to look at red colors, I could click on the red or the green or the blue. But what I want to talk about now, we're talking about grayscale. So if I slide this all the way over to the left, notice that the values here are identical. These are decimal values, 120, 120, 120, or the hex values of 787878, and that represents some particular shade of gray. As I move that up, the shade of gray gets lighter and lighter and lighter, and the values get closer and closer to 255 until we finally get all the way to 255, and they're just white. And of course the other end is just black at 0, 0, 0. So these charts are really pretty handy. You can set up specific colors to meet what your needs are as you're developing, for instance, a website. All right, let's go back to our presentation here. Another way of looking at the values in an image is through the use of a histogram. An RGB histogram is where the computer scans through the image and counts up the number of values at each level from 0 through 255. And you can actually glean quite a lot of information out of a histogram about a particular image. The lower part of a histogram is the lower third, roughly, is called the shadows. The middle part is called the midtones, and the higher part is called the highlights. You'll see these referenced in image editing utilities. And of course they're from 0 all the way up to 255. And then the value of the pixel number, it goes up. So what do these exactly do? Well, these help us to evaluate an image in terms of its tonal range. And you'll note that it's showing what the tonal range is here as far as what the width of this particular histogram is. So an example of that would be this particular black and white image. Notice on the image histogram here we're looking only at the gray aspect, and this is the breakdown as it's shown here in the histogram of the individual color channels, or in this case the gray intensity. Here's another example of a histogram that's showing us the tonal ranges and the areas that they represent on a digital image. So that the darker areas down here to the left are these areas in the image that are mostly black. The further you get up, the more lightness there is to it. Remember, this is from the lower part of the histogram on the left is black, and the right part is pure white. So all of these are somewhere in between. So you have lighter and lighter and lighter and lighter that shows the whole range of the photo. The histogram can also be used to evaluate the amount of contrast that's in an image. Contrast simply being the measure of the difference in the brightness between the light and the dark areas of a scene. So a broad histogram would reflect a scene with quite a lot of contrast, whereas one that's all compressed together would have a pretty low contrast. Editing images is a unique art in and of itself, and we don't really have any much opportunity to get into that. But just to give you an example, this is an image that I took at a car show once back in Colorado. And there's any number of editors that you can use, Photoshop, various versions of that, Microsoft Paint, and lots of other ones. There are also some online. This particular URL here would take us to an online editing thing, and we'll go take a look at that real quick. This is a website called Pixlr Editor, and from here I can open an image on my computer and bring it up, and there's a number of things. This is similar to most of your image editing utilities, where you have all these different tools over on the left and a menu across the top to do a variety of adjustments. This image is showing currently at about 57%, so if I was to use my mouse and roll that up to about 100%, we would be looking at the actual image as it was taken. That's not what I want. No, no, no. I can move this little window up here to focus on a particular area of the image. Notice if I was to roll in the mouse and zoom in on a part of the image here, you begin to see, once I exceed 100%, you start to see the pixelation of the image. And the more you roll in, the more of that pixelation you can see. This gives you an idea, as we were talking about, than how images are made up of individual pixels. But the more of them you have, the higher resolution, the further you get in, the less it looks like anything at all. But if we were to roll back to 100%, come on, there we go. At 100%, there's so many pixels in there that it looks like a seamless line, a seamless image where there's no granularity to it at all. The adjustment tools up here would allow you to look at the brightness and the contrast. Levels are typically referred to as the histogram. So here again you see the histogram on the screen, much like we were just looking at, with the output levels changing from black to white. This is a very stretched out image with a lot of more in the dark side. Here we're looking at the RGB combined. You can look at individual channels, red, green, and so on. You can also manipulate, change the white point, and adjust the image. So there's lots of things you can do to edit an image. Another thing I want to point out here is the eyedropper tool. The eyedropper tool can be used to pick out a specific color on the image. For instance, this yellow stripe over here. If I click on that, then you'll note down here on the left, it selects that color, and if I click on that, it'll bring up another dialog box which will show me what the values are in RGB decimal as well as the hex value for that particular color. It also shows what the hue, saturation, and luminosity are for that particular color. If I click over here on RGB, it can show you where that is in relationship to like a color wheel. And you can begin to adjust these things if you are so inclined to change the values. So you find that useful in one of the homework assignments because you'll be required to use an eyedropper tool to pick out the hex values of a particular image. All right, let's roll back to our presentation here. The other place you'll use the hex values for colors is in HTML and when you're using CSS. This is an example of an inline setting for color to set the color of a specific font blue. And you can find all of these values in lots of different places, including on the W3 Schools reference site. These are the CSS colors. And here it talks about the red and the green and the blue and how those are defined when you're using CSS. So you can use the color, the hex values. You can use this terminology with RGB and the individual decimal values. And then they go down and tell you all about how this is done and the different intensities. This is another example of the various intensities, for instance, of red. If only the red channel. If you had all zeros, of course it's black, but as you begin to increase the value in the red column, you get more and more red until this is the most red you can have, FF, in the red value column, and all zeros for the green and the blue. And then they also go through and talk about the different shades of gray and web safe colors. So it's a useful reference site. We didn't cover a whole lot on the CSS chapter, but this is an example of how to add a specific CSS style sheet to your web page. In my example here, I've placed it in the CSS folder. The name style.css is pretty much standard for doing that. Then you have to, this is the HTML that references and calls that. Here's an example of that particular file, style.css, and where we set up a background color, the hex value of CF, CF, CF. Now that would tell you what? That's since they're both the same, it has to be some value of gray, right? And here's a value of hex value E06900 for the H1 tag. So any place on the page that we utilize the H1 tag, it would come through in this particular color. Another thing in the CSS realm of things is positioning. There's a URL that you can look at here that talks about how to position things on your website using CSS, because some elements can be placed behind others. They can be placed to the top or bottom left. They can be placed in different positioning methods like static, fixed, relative, and absolute. In order to put a background image on your website, there's a W3 Schools page that shows you how to do that. These are the different CSS values that you can use to set up your background color, your background image, whether or not it repeats, and the position of it. And then they give you some specific examples on how to go about doing that. So again, the W3 Schools site is a great place to go for a reference on this kind of thing. And there's also a lot of free background images that are out there. For instance, the one I'm using on mine right now, it came from here. It was a paper JPEG or GIF file. Alright, so that is the end of that for now, and we'll just give you a quick example of that. If we go to our CSCI105.com site, and over here I've set up my little project portfolio page where it says instructor, and that takes you to the mgrimes.csci105.com, and the style.css sheet is displaying this. It's setting up the background image that you see here is this paper or linen-like background. That's a single square that's being repeated across the entire background. In this multimedia one, I have set that up to be a specific background image only for that table column and row. And then you can see the different other values as they're on here. And again, this is entirely up to you, and I would encourage you to go ahead and personalize your own project portfolio page with some different backgrounds and different text colors and even fonts if you so desire. At this point, it's entirely up to you how you make your project page. So get creative and have a little bit of fun, and that'll wrap up this presentation.